I'm Terence Law, and I'm a PhD student at the Visualization Lab at Georgia Tech. I'm going to be presenting our work on understanding how interface design may affect users when they audit machine learning models for algorithmic biases. Decision makers in different domains have started to use machine learning. For example, in hiring, some recruiters use machine learning models to predict the future performance of job applicants to determine whether to hire them. The problem with these models is that they can be biased against some demographic groups. Reuters reported that an AI recruiting tool developed by Amazon biased against women for software developer jobs and other technical posts. To avoid using biased models to make predictions, we need to detect these biases before their deployment. One approach that has received significant attention is to use a human-in-the-loop approach. So here is how a human-in-the-loop bias detection pipeline works. Let's consider a fictitious job performance prediction scenario. It is also a scenario we use throughout our paper. You're a recruiter and you want to learn about the biases in a resume screening model. Your model takes a resume as an input to predict future job performance. You want to test the model on your current employees. So you have collected your employees' data. Your data have the demographic information of your employees, such as ethnicity, gender, and marital status. Based on the employee's resume, your machine learning model makes predictions about their job performance. The model puts the employees into three buckets. Above means above the performance expectations. Meet means they meet the performance expectations. Below means below performance expectations. You want to know how accurate these predictions are? Because they're your employees, you also have their actual performance for assessing how well the model does. With this data set, you first specify what you want to analyze. Let's say you're interested in learning about whether the model is biased against ethnic and gender intersectional groups. Ethnic and gender intersectional groups are groups formed by the intersection of ethnicity and gender. Some examples are Hispanic males and Asian females. The bias detection tool then generates a bias report. What you're looking at is a table where each column is a demographic group. There are many other demographic groups in the table, but let's focus on Asian males for now. And each row it's a performance measure such as overall classification accuracy. For each class, it also shows the classification rate. For Asian males, the classification rate for meet is the proportion of Asian males that are classified as meet. So in this case, 90% of the Asian male employees are classified as meet. It also shows the false positive rates for each class and false negative rates for each class. Besides simply showing the performance measures, the bias report also tells you whether your model is biased against Asian males. What it does is it compares the performance measures of each demographic group with its complement. For example, the bias detection tool compares the measures of Asian males with those of people who are not Asian males. There are a few measures that get a pretty large difference between the two groups. For example, the false positive rate for below is pretty high. It means that the model tends to misclassify Asian males as below more frequently. So the model reports the performance measures along with the potential biases for each demographic group. And as a recruiter, you can review the bias reports to determine what are the important biases in your model and what are not. There are different approaches to presenting the bias report in a user interface. And our question was, how does the interface design affect the biases users find from a machine learning model? To answer this question, we created two bias detection prototypes. One of them uses visual cues for presenting the automatically detected biases in the bias report. Another one uses a recommendation list for presenting the automatically detected biases. These presentation styles are common in existing bias detection tools. We conduct a lab study to understand how people use the prototypes to look for biases in machine learning models. Let me explain these two presentation styles before I describe the study. So here is our bias report for Asian males. To indicate how the model biases against Asian males, a bias tool can simply highlight the performance measures that it considers to indicate potential biases. So this is the visual cue approach. Based on this idea, we developed a bias detection prototype that uses visual cues to highlight the problematic performance measures. In the interface, users first select the attributes they want to investigate further. For example, if you select ethnicity and gender, the interface will show some panels. Each panel is a demographic group. The panel shows all the performance measures for the demographic group. For each performance measure, users can also see the corresponding measure for the complement group. The measures that have a large difference from the complement group are highlighted in pale yellow. There are other interactions supported by the prototype. You can learn more about the prototype by reading the paper. Another way of presenting the automatically detected biases is to use a recommendation list. A recommendation list simply shows the measures that indicate potential biases in a list, but it provides an option to look at all other performance measures. So here's the prototype that uses a recommendation list. It allows users to select the attributes they want to investigate further. This time, the interface shows a list of entries. Each entry in the list shows a performance measure for a demographic group. There's a large difference from the same measure of the complement group. To look at all the performance measure of a demographic group, users click on the demographic group label and a panel is shown. The panel shows all the performance measures for that particular demographic group that you have selected. Again, please refer to the paper to learn more about the prototype. But with these two prototypes, we can really answer this question. How does interface design affect the biases users find? So we conduct a lab study to observe how people use the two prototypes for detecting model biases. We've recruited 16 machine learning developers from a large technology company to use our prototypes. These people build machine learning models in their job. It was a within-subject experiment with two conditions. So participants used both prototypes to detect biases in machine learning models. The presentation order of the prototypes was counterbalanced. If a participant started with the recommendation list prototype, here is what she did during the lab study. Participants first read the job performance prediction scenario that I have been talking about. In this scenario, there were two companies. Each had a performance prediction model. Participants were asked to detect biases in the first model using the first prototype, and the second model using the second prototype. Participants then read a bias report for intersectional ethnic and gender groups using the first prototype, which is the recommendation list prototype in this case. In a prototype, there is a button next to each performance measure. They were asked to select the measure they wanted to investigate further. Again, participants could also click on the demographic group label to see all the performance measure of the demographic group. They had at most 10 minutes to find biases using this prototype, and at the end of the session, we asked them to explain the set of performance measures they selected. They then used the prototype with visual cues to read the bias report for intersectional ethnic and gender groups. Again, we asked them to select the performance measures they wanted to investigate further. They had at most 10 minutes, and were asked to explain what they selected at the end. And finally, they fill out a questionnaire about which prototype they preferred more for detecting biases in machine learning models. Here are the important findings. We learned that users might be less comprehensive in bias detection when they read a bias report that uses a recommendation list. On the other hand, the prototypes using visual cues might cause information overload. So let me first explain how the recommendation list might lead to incomprehensive bias detection. So there are basically two types of performance measures that I have been describing. The ones that were automatically reported by an algorithm to indicate biases, and the ones that were not reported. We found that participants selected significantly fewer performance measures that were not reported when they used the recommendation list prototype. Another finding was that participants often considered some unreported measures important. They selected these unreported performance measures and provided valid reasons for doing so. For example, in some cases, a performance measure of a demographic group has an extreme value like 100%. This value might be very similar to that of the complement group, but participants felt that it indicated potential biases, and they selected these kinds of performance measures. So, any bias detection tool is imperfect and will miss some performance measures users care about. When users use a recommendation list, they tend to select the unreported performance measures less, although these performance measures can still be important. This can lead to users not being comprehensive in detecting model biases. Another finding is about information overload in the prototype using visual cues. Participants' preference for the prototypes was mixed. For the prototype using visual cues, participants felt that showing all information, all of the performance measures, allow easier comparison of the performance measures, but it was overwhelming because it showed too much information at the same time. So these are the two main takeaways. The visual cue prototype can cause information overload, while the recommendation list prototype can cause incomprehensive bias detection. I want to highlight this finding because it tells us that how you design a bias detection tool can actually affect the model biases users can find. So we need to design bias detection tool really carefully. And in the paper, we have provided some suggestions about whether to use a recommendation list or visual cues in what scenario when designing a bias detection tool. You can take a look at our paper to learn more. With that, I would like to thank my collaborators and Adobe for their support, and that's the end of my presentation. Thank you.